Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper for the year 2022 for additional mathematics for Selangor paper. And this is paper 1, set 1. Okay, let's get started with question number 1. Okay, so I'm going to do part A over here. So the first thing is we need to find the values of P and Q given this whole expression. Now it looks very complicated and long, but it's not really that difficult. Okay, so number one, what we can do is we can break up the whole expression, combine the three. You can see a 3 power P and 3 and a 2 there. Yeah, the numbers put aside, and the one involving Y we put aside, because you can see on your right hand side we have Q over Y squared. Q will be a number, Y would have a power of 2. So we need to express Y on the left hand side and compare with the Y on the right hand side. Yeah. Okay. Well, we can just, number one, write this P squared over 3. Don't do anything with this first. This power 3 over Y cubed, you must power P. Remember, A power M, when you power N, you get A power M times N. So in this case, we have 3 power P, and your Y power 3, you must times P. Then for your second term, the Y over 2 power P plus 2, we power them one by one, Y power P plus 2, divide by 2 power P plus 2. Okay, now this is now Q over Y squared. So I'm just going to keep my Y squared as it is. Okay, next, let's group them together. Let me just put, maybe put a number in front. The number in front is 3. And or we do P over 3 power P over 3 put together. Now you still have a 2 here, 1 over 2P plus 2. Well, you can put a P squared on top if you want. And then you have a Y power P plus 2 and a Y power 3P. So what we want to do is to simplify this whole thing. I'm going to simplify this whole expression. And we can see that when you divide A power M divide A power N, we minus the power. So in this case, 3 power P minus 2, 1. And you keep your P squared and your 2P plus 2. When you divide the Y, also you minus power. But however, please take note, your Y on the right-hand side is written below. So therefore, I prefer to bring the Y power P plus 2, I bring it down. So when you bring it down, it becomes 3P minus P minus 2, right? And this is now Q over Y squared. Okay, as we simplify this further, keep this P squared. Now, you can put the 2 together, 2 power P plus 2, bracket, and then there's a P squared outside. This will be a 1 over Y power 2P minus 2. And your outcome should be Q with a 1 over Y squared. So I purposely write them separately, but you don't have to write them separately. You can put them together. Now, the next thing is we want to compare. So you notice there is no point comparing this first because I can't solve for P or Q, right? So we want to compare the second one first. The second one is this, your base of Y. When you compare your Y, yeah, let's write here, compare your Y, what do you see is your Y has a power 2P minus 2. And on your right-hand side, your Y has a power 2. So when you bring this over, your 2P is now 4 and your P is just 2. Okay, then we compare the number. The number means the one, yeah, on the right hand side here, the one I underlined with red color here. When you compare number, on the right hand side we have Q. On the left hand side, we have 3 power P minus 1, 2 power P plus 2 with a P squared. Now that I know P is 2, I think we can substitute P with 2 straight away. So this will be 3 power 2 minus 1, 2 power 2 plus 2, and there's a 2 square. So you get a 9, 3 power 1, which is 3. Yep. 2 power 2 plus 2 is 2 power 4. 2 power 4 is 16. As you multiply by 4, answer 3 over 4. But it looks like I don't have enough space for part B. Okay, so maybe I do part B on the right-hand side here. Part B, we're supposed to evaluate logarithms. So let me do it on the right-hand side here. Okay, in this logarithm, you can see their bases are different. One has base surd y, second one has base x, the third one has base 3. So generally speaking, it's easier to change everything to the base of a number rather than unknown, generally. So I'm going to change the base. Now, remember the formula for changing base looks like this. Log base AB is log, you put the original number on top, original base below. Introduce a new base. The new base is C and C. Okay, so in this case, I'm going to use base 3. Original number 9 stays on top. Original square root y stays down, right? And original base is square root y. And your new base, I put 3 and 3. Then the second one also, you can see here, the log base xy, I change the base again. So y stays on top, x stays down, 3 and 3. Now, since the third term is already in log base 3, right? So I'll just leave it as it is, yeah? Let's write log base 3x. Okay, next, what do I do with log base 3? 9. Now, we know 9 is 3 power 2. So we can straight away, you can just write this as 2 straight away. Yeah? You can actually evaluate using this calculator, log base 3, 9. Can you see? It's just 2. You can write 2. Okay, for your square root, there's a power half here. There's a power half here. We bring the power half in front. So it's going to be a half here. You multiply with log base 3y. As for the log base 3x, now notice we can actually cancel them right away. See from here, you can just cancel them. All right. So that would be eliminated. We don't need that anymore. Now, next, we can actually eliminate this as well. We can cancel this too. Once you bring the power square root half, right? Power half you bring in front. And we know this is just log 3 is 1. So we have to divide by half. Well, 2 divided half is the same as 2 times 2 over 1. Well, my answer is just 4. There you go. That's the answer for question number 1. Okay, question number 2. Now, this question is from the chapter system of equation, but it's a bit weird as in normally system equation, we have 3 unknown, x, y, z, or we have 2 unknown, x and y, but one of them is linear, one is non-linear. But in this case, we have here is a pair, or should I say 2 pairs of linear equation. Okay, well, the first equation is 2y equals to 7 minus x. We can choose to make one of them as a subject if you want to use substitution, or you can use elimination. Well, I think in this case, I use substitution. I transfer this over, x is 7 minus 2. I can call this equation 1. The interesting part is the second equation, because in the second equation, you can see it's a modulus x plus y equals 4. Now, remember, when you open up a modulus, there is always a plus minus. Reason being, when you modulus negative 4, you get 4. When you modulus positive 4, you will also get 4. Modulus means the magnitude. We want to find the magnitude, right? So your x plus y is inside your modulus. It can either be negative 4 or it can be positive 4. So in this case, we have 2 pairs of equation. This is your, let's call this equation 2. Let's call this equation 3. So we have to solve for both equation 2 and 3. All right, 1 and 2 and 1 and 3. So let's say we just sub 1 in 2 first. Yeah, let's get rid of x, find y. Okay, the moment you sub inside, you don't write x, you write 7 minus 2y, you plus with y. The result is negative 4. 7 minus 2y plus y is minus y. You get negative 4. You can bring this over. Your y is now positive y. Negative 4, bring over to the left. You get 7 plus 4. Y is 11. Now, remember, you have to solve for x and y. You got y, you need to find x. You sub inside equation 1. Your x is 7 minus 2 times 11. Basically, it's 7 minus 22. 7 minus 22. Negative 15. You can just use your calculator. There you go. Yep. All right. Next, I also need to sub equation 1 inside equation 3 because I need to solve the second pair of equation. All right. When I sub inside, my x is 7 minus 2y. You plus with y, the result is 4. So your 7 minus y is now 4. Bring this over. Your y is 7 minus 4. Your y is 3. Again, we need to find your x as well. So we sub inside equation 1. My x is 7 minus 2 times 3. Basically, 7 minus 6. 7 minus 6 is 1. All right. Okay. The next question is from the chapter progression. In fact, it's a geometric progression. So now I hope you have some background on this because this is from the Form 3 chapter, Consumer Mathematics, right? The compound interest. So here, the first thing they say, since 5 years ago, Suhaila saved 15,000 in her saving account with an interest rate of 4.5% per annum. The saving received compound interest every 6 months of the year. Now, actually, there's a formula in Form 3. They call it matured value, and it's given by principal P 1 plus R over N power NT, where R is your interest rate, N is your number of times you compound it in a year. Okay, now unknowingly, people didn't realize that this is actually a geometric progression. Okay, so you can either use the formula directly, ignoring geometric progression, right? Or you can use the concept of geometric progression as well. Okay. So now let's say I just want to use the formula directly. I just explain both ways. We want to find the how much money she has amount, because if she never made any additional saving or withdrawal, all right, and this is after 5 years. Okay, so the first thing, if you want after 5 years, so you know your N should be 5 times 2, which is 10, right? Because 1 year you compound twice, right? N is a number of times you compound it. So we can say the amount matured value equals your principal, 15,000 here. 1 plus your R is your interest rate, 4.5. In decimal, 4.5, you need to divide by 100 is 0.045. You divide by 2 power 2 times 5. T is number of years. So in this case, it's 10. So let's just work it out. Okay, let me calculate over here. 1 plus 0.045 over 2. This is going to give us 1.0225. So this is 15,000, 1.0225 power 10. Okay, so take this 15,000. Okay, if you're lazy, just put the answer there, because this is 1.0225 that we talk about. This is power 10. There you go. I got 18,738. Yeah, RM, 18,738. Now, notice I didn't use any progression at all, right? Because if you remember this formula, you can just use it directly. Okay, let's say you can't remember. Well, one thing you need to know about progression is that geometric progression, you always have to start by finding the common ratio. Now, we know interest rate, right, is 4.5 per annum, but per 6 months, you take this, you divide by 2, you get 2.25, right? Every 6 months, you get 2.25%. So from the start is T1. So after 6 months, you get T2, right? And your common ratio is T2 divided T1. So in your T1 is 100%. T2, you get extra 2%. So it's 102.25, extra 2.25%, right? So when you take this 102.25, you divide by 100, you actually get 1.0225. Okay, so that's where you got this number over here, right? Now, remember this, after 6 months, you get T2. After 1 year, you get T3. So after 5 years, that means 5 years is 5 times 2, 10, 6-month period. 6-month period. So after 10 6 months period, what we get is actually T11. We don't get T10, we get T11, right? So every 6 months, you compound it. So it's T11, and T11 is given by A, R, N minus 1, which is 10. Yeah, remember, Tn formula is given by A, R, N minus 1. So notice it's the same, exactly the same as what we have over here, right? Of course, if you have this formula, it's a lot faster. If you don't remember, well, you can just use the formula for geometric progression, the end term of a geometric progression. Okay, first part, we are done. We got this answer. Either use the first method, right, which is the formula here, or the second method, which is the geometric progression formula. Okay, next one. The amount compound interest earned by her. Okay, this is very simple because she put in 15,000. She got back 18,738. So what is the amount of interest that she earned? Oops. Her interest is 18,738. You minus 15,000. So she actually earned 3,738. Right? If you want more decimal point, you can actually write more decimal point. Previously, I didn't. I just wrote 18,738. I think it's good enough. Yeah, you want, you can put a 0.05 and add a 0.05 at the back here as well. Okay, but this is already a 5 significant figure. But if you want, add a 0.5 here, 0.05 here, 0.05 here to get the full amount, the full exact amount, including the cent. Okay. Okay, question number 4. This is from the chapter trigonometric function. Yeah, from 5, chapter 6. Okay, so first part. Now this looks like a past year question that we've done before. All right. We start off when it comes to proving, we start from the side that's more complicated, move towards the simpler one. In this case, the left-hand side looks a bit more complicated. So we have to use what we call the addition formula. Now, remember, formulas for sine A plus minus B, and in fact, this formula is given, is sine A cos B plus minus cos A sine B. So in this case, your left-hand side will be sine X cos 45. Because we start with plus, so I put a plus here, cos X sine 45. Now, notice that we had to multiply with another sign here. So you're going to do one more time, but this time is minus. So let me put a bracket here. This is sine cos minus cos sine. Okay. All right. Now, we know cos 45. You can actually use a calculator. Cos 45 is Surt2 over 2. Okay. But if you use a triangular method, right? If you draw a triangle, a right angle triangle, that is isosceles, this is 45, this is 45, this is 1, Surt2. Then your cos 45 is 1 over Surt2. Now, take note, they're actually the same. Whether you use a calculator directly or use this, actually the same, because when you rationalize the denominator, you actually get Surt2 over 2. Okay, but for this question, I'd like to use 1 over Surt2 because it's slightly easier, but if you use this, it's still okay. All right, so this is sine X 1 over Surt2 plus cos X 1 over Surt2. Let's put a bracket here. And by the way, sine X, cos X are the same because if you read sine X, sine 45, sine 45, cos 45 are the same because if you read sine 45, you get 1 over Surt2 as well. Look at this. Now, if you don't believe me, calculator, sine 45, still the same, Surt2 over 2 or 1 over Surt2. Okay, so here we write sine X cos 45, same thing, 1 over Surt2, cos X, sine 45, 1 over Surt2. Now, notice we can actually factorize your 1 over Surt2 from here. For the first one, I'm taking out this and this. So I'm left with sine X plus cos X. Now, for the second, I'm going to take out this, the same term, right? 1 over Surt2 again. I'm left with sine X minus cos X. Yeah, let me put a bracket. Now, look at your right-hand side. I'm supposed to get a negative cos. I'm supposed to get a negative half cos 2x, okay? Now, number one, I think we can take these two and multiply together, right? You square it. This is sine X plus cos X, sine X minus cos X. Now, remember, when you expand like a plus b and a minus b, when you expand it, you get a squared minus b squared. So, and when you have 1 over Surt2, you square it, you just get 1 over 2. So this is your sine square x minus your cos square x. Well, you can always take a sneak peek at your right-hand side. At your right-hand side, you have cos 2x. And cos 2x has 3 formula, okay? Well, the first formula for cos 2x is cos square minus sine square, right? This one you can find from the list of formulas given in exam. But here what we have is a sine square minus cos square. Now you notice that this is the other way around. This is cos square minus sine square. Well, we can take out negative from here. This becomes cos square x minus sine square x. And your cos square minus sine square is this cos 2x. Can you see? Cos 2x, right? So there's a negative half here, right? So we are almost there. Just write negative half cos 2x. There you go. That's your right-hand side. Okay. All right, second one, part B, I'm going to do over here. Yeah, part B is a little bit longer. We have to draw a triangle. Your cos 2x is negative 5 over 13. Now we know x is between 90 to 180. So 2x is between 180 and 360. So I'm going to draw a triangle, but this triangle must be in quadrant number 3. Why so? Well, because your x is your 2x between 180 360 is a reflex angle. 180 is here, 360 is here, 270 here. Now you may wonder why quadrant 3? Why not quadrant 4? Well, if you go back to your ASTC, quadrant 3, only tangent is positive. Quadrant 4, cos is positive. Now your cos here is negative. See this? Your cos here is negative, right? The cos value is negative. So it can't be quadrant 4. It has to be in quadrant 3. So this is your 2x. And I hope you remember, when we write 5 over 13 means your adjacent is 5. But you have to put a negative. There's a negative here. Maybe I'll put a blue pen here, negative 5. Your hypotenuse is 13. My opposite is 12. Now you may wonder, how do I get 12? Well, Pythagoras, 13 square minus 5 square. Although you have a negative 5, right? But it doesn't matter. Negative 5, if I square it, is still a positive. Then you put a square root over, you get 12. And remember to put a negative here. Why? In your coordinate system, right, anything below the x-axis, your value is negative. Notice this is negative. Anything on the left-hand side of the y-axis, the value here is negative. That's why your 5 and the 12, we have to assign negative in front. Okay, now, why do I use this triangle? Because I want to find tangent x, right? I need to first find what is tangent 2x. Now we go back to the formula for tangent 2a. This formula is given in SPM. So it's 2 tangent x over 1 minus tangent square x. And when you read from this triangle, you can see your tangent is your opposite, which is negative 12. Divide your adjacent, which is negative 5. So the reason why they give us cos 2x here is to help us to find out what is your tangent 2x. And once you know your tangent 2x, we can find the value of tangent x by using your double angle formula. So here my tangent 2x is 12 over 5, and it is positive because negative 12 divided negative 5 is positive. Okay, our job is to solve for tangent x. Okay, what we can do is we can cross multiply here, 12 minus 12 tangent x. Okay, in fact, before you multiply, I'm thinking, can we cancel this? 12, you can divide by 2, you get 6. So the number is smaller, right? Don't need to, divide by 2 later on. I just cross 6 minus 6 tangent square x, all right, equals 5 tangent x. Bring everything to the same side. 6 tangent square x plus 5 tangent x minus 6 equals 0. Let us double bracket factorize. Okay, so when you factorize, we take 6 times 6. 6 times 6 is 36. Factor 36 is 36. 1, well, 18, 2, 12, 3, 9, 4, 6, 6. And which combination gives us 5? I want 5. I should use 9 and 4. So to get 9 and 4, I put a 3, 2 first. All right. One of these must give us 9. This one must give us 9. This one must give us 4. So to get 9, I put 3. To get 4, I put 2. And in order to get positive 5, the bigger number 9 is positive plus smaller number 4 is negative, right? So here your tangent x is either 2, well, did I make a mistake here? 2 over 3, 2 over 3. This one should be 9, 4. 9, 4. 2 over 3 and negative 3 over 2. Okay, 2 over 3, negative 3 over 2, 9, 4. Okay. Well, now we know tangent here, your x is between 0 and 90. So that means it's quadrant number 2. Yeah. It has to be quadrant 2, 190 to 180. So quadrant 2 tangent is negative. So we can't take positive value. Yeah, we say it must be less than 0. Therefore, there's only one answer. Your tangent x is negative 3/2. Right. Okay, question number 5. Okay, this question is supposed to be coordinate geometry, but it actually use a bit of quadratic equation. Yeah, the chapter quadratic function, the b squared minus 4ac. Okay, let's get started. The first one, you have an equation of locus of R is given by this function. You're supposed to show that locus R intersect the x-axis at two different points. Now, we know at x-axis, your y is always 0. So I'm going to let y be 0. By replacing your y with 0 here, your y is 0 here, I got x squared minus 9x plus 18 equals 0. Right. Now, here we have two different methods. Method 1, we can go and solve it. Method 2, we can do b squared minus 4ac. Now, it's not difficult to actually factorize this directly. We can actually just factorize it and say x factor of 18. What's the factor of 18? We can use 9, 2, 6, 3, 18, 1, 18, 1, 9, 2, 6, 3. Now, the combination that gives us 9 is 6 and 3. So I can put 3, I can put 6. There you go. I got x equals to 3 or x equals to 6. Now, we know at x-axis your y is 0. So your coordinate point intersection is 3, 0 and 6, 0. We found the exact coordinate. So therefore, we can just come up with a conclusion that R intersect the x-axis at 2 points. Yeah, pretty simple, right? Because we can actually solve it. But if some people don't want to solve it, because we say, well, to show that it has two real root, to intersect 2 points, it must have two real root. And in order for it to have two real root, your b squared minus 4ac value must be more than 0. So let's take our b negative 9, you square it, minus 4, your a is 1, your c is 18. Okay, so let's do 9 squared minus 4 times 18. So this gives us 9, right? Which is more than 0. Yeah, pretty easy. And we can actually write the same conclusion. R intersect the x-axis at 2 points. Okay. Well, for part B, they say this straight line is now a tangent to locus of R. You're supposed to show that it's a tangent. Well, a line's a tangent when it touches the curve at one point. In this case, a circle. So I draw a circle, touches at 1 point. So we need to show that there's only one solution, or we can do b squared minus 4ac equal 0. Okay, so we call this equation 1, call this equation 2. This is part B over here. I'm going to sub equation 2 inside equation 1. So we don't write y, we write minus 3x plus 8. All right, we square it. Then you minus 9x, write another minus 3x plus 8. Then you plus 18, your outcome is equal 0. So let's expand this. This is going to give us x squared, 3 squared, negative 3, if a square is 9. 3 times 2, I hope you can do 2ab directly. 2 times negative 3 is negative 6. Negative 6 times 8, negative 48. And 8 squared is 64. Well, minus 9 minus 3 is minus 12. 8 plus 18 is 26. Okay. Now we can simplify this further. These two, we can add them up. Well, these two, we can add them up. And the last two, we can also add them up, right? So this is going to give us 10x squared minus 60x. 64 plus 26 is going to give us 90, right? Now notice in this case, we can divide everybody by 10. So we get x squared 6x plus 9 equals 0. Now again, you have two different methods. You can choose to do, you can choose to solve for x, which is not difficult because this is exactly in the form of what? A squared, 2ab b squared. When you factorize it, it's a plus b squared. So in this case, it's x minus 3 squared, right? So we know there's only one solution, x is 3. We just have to sub inside either one equation, either equation 1 or equation 2. I like equation 2 because it's easier. This is 3 plus 8. I got negative 1. So therefore, your coordinate is 3 minus 1. Okay, well, if this coordinate 3 minus 1 means what? It touches 1 point, right? So therefore, we can conclude that, yep, straight line, or can I just write the equation y equals minus 3x plus 8 is a tangent to locus of R. Now, of course, the second way we can do b squared minus 4ac, which is fairly simple. Your b is negative 6. I square it. 4a, a is 1, c is 9. So this is 36 minus 36, which is 0. If your b squared minus 4ac is 0, meaning you have only one solution, right? One real root. And therefore, the straight line should be touching the circle, the locus at one point. And we can come up with the same conclusion. Okay, so whether you want to use method 1 here or method 2 here is up to you. All right. Okay, question number 6 is from the chapter function. Okay, so the first part, they give us the inverse function is defined by this. And then it's stated here, your x is not k. Now, remember, a function becomes undefined when your denominator is 0. Any number you divide by 0 is infinity. It can be 2, can be 1, can be any number, right? We divide by 0, you get infinity. So in this case, your denominator is 3 minus x. You let it be 0, your x is 3. Now you notice your x cannot be k. Or in this case, your k is just 3. All right, for Roman 2, I'm going to do it here. Remember, there are two different methods of inversing a function. So some people let whatever you're finding becomes x, some people let whatever you're finding becomes y. So in this case, I'm finding hx, okay? I'm finding hx. So method 1, for me, personally, I like whatever I'm finding becomes y, yeah? Then I interchange h inverse y, let it be x. Okay, just to explain quickly why it is so. This is x. When you move forward, you get y. When you move backwards, you get x. So in this case, I am finding h. Okay, so I'm finding what? I'm finding my h in. I'm finding my hx. I'm finding my y. Okay, so my h inverse, I already have it. Okay, my h inverse is 2 over 3 minus x, but this is y, so I put a y here. Okay, 2 over 3 minus y. And remember, I'm finding hx, so I'm finding y actually. So let's make y as the subject. Now, again, here you have two different methods. Some people multiply up one by one, as in they write 2 equals 3x, 3x minus xy. Since I'm finding y, we make y as a subject. I'm going to bring this over, right? So I got xy equals 3x minus 2. Since I'm finding y, right, I divide. So I got 3x minus 2 over x, and my y is my h in hx. I'm finding hx, my y. So this is 3x minus 2 over x. And since your denominator has x, right, and your denominator cannot be 0, so we write x not equals to 0. Now, on the other hand, some people may say, oh, for me, personally, I don't like to do this. I like to switch up and down. 2 over x equals 3 minus y. Yeah, the entire 3 minus y, I bring it up. The x, I bring it down. Just switch it over. And bring the y over, bring this over. Your y is 3 minus 2 over x. And what's your y? Your y is your hx. Your hx is 3 minus 2 over x. And your x not equals to 0. Now, they're actually the same thing, because if you were to combine this as a single fraction, by multiplying top and bottom by 3, this 3 I times with x, I get 3x. I divide by x, right? And I put them together, I'm actually getting the same thing, right? But it's up to you. You can reuse the first method, second method, up to you. Even then, right, like some people may say, oh, I let h inverse x becomes y, then my 2 over 3 minus x becomes y. Well, I find x is the same thing. You can make x as a subject, but up to you. You can say I bring the 2 over y equals 3 minus x. X is 3 minus 2 over y, and your x is your h. X, it is 3 minus 2 over x. You can do that. Yeah, x not equals to 0. Okay, that is method, the first part. Yeah, I show you a lot of different method, up to you, whichever you're more comfortable with. All right, move on to the second part. You're given fx. This is part B. It's part B here. Your fx is now ax plus b, and g inverse is this. F g inverse equals 4 plus 3x. Actually, the g inverse is there to confuse you. It has nothing to do with anything because you see, this is g inverse, this is g inverse. We don't have to inverse the function. So what we need to do is to put g inverse inside f because this is your f g inverse. Okay. So let me put your f g inverse inside x plus 5 over 2, and I write this with 4. I write this as 4 plus 3x. Take this, put inside your fx. Your fx is ax plus b here. If I put x here, I must put x here. If I put a bracket here, I need to put the same bracket inside. Okay, let me just write the 3x in front, the 4 at the back. Now, we have to expand or simplify this, multiply your a inside 1 by 1. So this is a over 2x, 5 over 2a plus b. The result is 3x plus 4. Now, let's compare the coefficient of x with the coefficient of x because I'm finding for a. Right? So your a over 2 is 3, a is just 6. I'm comparing the coefficient of x. The second one, we compare the constant. Constant is a number without any x. Yeah, the term without any x. So we have 5 over 2a. Since my a is 6, u plus b, the result is 4. 6 and 2 can cancel, left with 3. 5 times 3 is 15, right? Bring the 15 over. 4 minus 15, b is negative 11. All right. Okay, the next question is from the chapter Linear Law, chapter 6 from 4, but it combines a bit of coordinate geometry here. So here we have two variable x and y. They are related by this equation, right? Now we can see the diagram shows a straight line obtained when you plot xy versus x squared. So we have to convert this to linear form by multiplying. I need to get xy here, right? I got 2y here. So starting from this equation, I'm going to multiply by x. I'm going to divide by 2 because I don't want the 2 in front. I want xy. And then you multiply by x. Okay, so when you multiply by x over 2, your 2 disappear. You add x. All right. As for m minus 1, right? You keep the m minus 1. You have an x. You multiply one more x, you get x squared. You divide by 2. Now I'll put the 2 in front. You can put 2 underneath x squared, up to you. I like to put in front so you can compare, and this is your gradient. Whereas for 10, right? 10, when you multiply by x, you divide by 2. There is originally an x here. Maybe I do a bit slower here. There's originally an x over here. You multiply by x over 2. So we cancel this. So once you cancel, let me write this separately. You're left with 5. So remember, you're supposed to express in linear form. So this is your big Y, this is your M, this is your X, and your C. You don't have to draw this arrow here. You don't have to. You can stop here. Good enough. All right, that is part A. So part B, you're given the gradient of this line is now PQ is now 1 over 3. Now you can see a PQ is a line perpendicular to RS. You're supposed to find the value of M and N. So first you need to find what is the gradient of RS. Okay, so this is part B. Now we know PQ times RS, PQ, which is 1 over 3, multiply with gradient of RS, the result is negative 1. My gradient of RS is now negative 3. Now, from your graph, your straight line, the linear form that I've got here, my gradient is m minus 1 over 2. I equate it with negative 3. So let's multiply over. This is negative 6. The 1 bring over my m is negative 5. Okay, for your y-intercept, my y-intercept from the graph, I already have it here, is 5n. I want to compare with the y-intercept that I got from the equation, which is 5. So my n is just 1. Okay. Okay, the next question is from the chapter vectors. So here we have a triangle ABC. K is a point on line BC such that the ratio BKKC is n to 2. Your vector AB is 3x. Your vector AC is 6y. You're supposed to find BC in terms of x and y. Okay, so number one, how do you find BC? Okay, so BC, if you look at the diagram here, I need to go from B to A to C. So if I'm going from B to A, right, it's negative 3x. If I'm going from A to C, it's positive 6y. Yeah, you can actually stop here. You can put 6y in front, minus 3x at the back. Yeah, that's it. Okay, the second one, how about AK? Well, I want to find AK. I can go from A to B. Okay, I'll show you the slow way. Then I'll show you a fast way after this. AK is A to B plus B to K. Now, A to B is 3x. B to K is, okay, you have to look at this. Now, BK is a fraction of BC. BK over BC, you can see, is the ratio is n. The whole thing is n plus 2. So when you multiply up, your BK is just n over n plus 2 of BC. For example, your n can be 1. So your BK is 1, right? Your BC should be 3. 1 plus 2, 3. Yeah? So you multiply over BK is 1/3 of BC. But in this case, you have to leave your answer in terms of n. Okay, so in this case, can we just sub inside? This is n over n plus 2 of BC. And I already know my BC from the first part. Yeah, my BC is this 6. You can write minus 3x plus 6y. You can even write 6y minus 3x. So let's multiply inside. This is 3x plus, okay, I'm going to times it, so it becomes a minus, minus 3n over n plus 2x times, okay, this one times inside. I hope we can see this. I'm multiplying inside 1 by 1. This is 6n over n plus 2y. Now I just have to group them together. These two, when you group together, notice that your coefficient of x, your 3 here, it doesn't have this denominator. So we need to multiply top and bottom by 2. Maybe I write like this, 3n plus 2, right? Then I put them together. This is minus 3n. Divide by n plus 2. Take out the x. This is 6n, n plus 2y. Okay. Now let us expand this bracket. 3n plus 6 minus 3n over n plus 2x. This is 6n, n plus 2y. Your answer is 6 over n plus 2x plus 6n over n plus 2y. Okay, you may think, wow, this one looks really, really difficult. Well, actually, it's not. If you know how to use the ratio theorem, it's so easy. Now, in coordinate geometry, you learn this, right? nx1, mx2, m plus n. Now we do for x, we do for y. Now, actually, this formula is applicable for vector as well. So I want to show you the shortcut. All right. So this is your, you may want to call this as your mn, doesn't matter whichever comes first. But the most important thing when you use the formula is that they must be opposite. So 2 must multiply with 3x and n must multiply with 6y. So we say 2 times 3x. Okay, let me write here 3x. And then n, you multiply with 6y. Your total ratio is m plus n. In this case, is n plus 2. Okay, so let's put them together. 2 times 3 is 6. 6 over n plus 2. Separate x. The second one, n times 6, is 6n over n plus 2. Y. Oh my, this is so easy. Yeah, short and simple. Okay. Okay, question number 9. This is from 5, chapter 1, circular measure. Okay, this question is quite simple. You're given OP is length of arc QR is 9 cm. OP equals to OS equals to PQ equals to SR. They are all 7.5, 7.5, 7.5, 7.5, 7.5. Okay, now you're supposed to find the value of beta. Beta is angle. Now remember, we can use S equals to R theta. Your R is now 15. The length from here to here is 15. Your length of arc is 9. Your theta is now beta. So let's take 9 divided by 15. 9 divided by 15 is 0.6, right? 305, 0.6. Can change to decimal. 0.6 radian. Yeah, simple. Okay, area of the shaded region. Now, if you know how to use half AB sine C, your life will be a lot easier. Otherwise, you have to count one by one, right? So you know about that when you have a triangle, let me just write over here. So let's say this is length of side A, length of side B, this angle is C. Your area triangle is given by half AB sine C. You learn this in solution triangle, form 4, chapter 9, right? Now, look at the triangle that you have here. This triangle has a length of 1.15, 7.5, and we know the angle in between is beta. You're finding area shaded region. So you're taking this sector, you're subtracting this triangle, right? Where this is 15, this is 15, and this is 7.5. And the angle beta is 0.6 radian. So this is 15, 15, 0.6. Yeah. Okay, so we're going to use half r squared theta to find the area sector. Your radius is 15. You square it, your theta is 0.6. Then for area triangle, I use half AB sine C. AB sine 0.6 radian. Okay, so let's calculate this. Okay, your half AB will be r squared first. R squared theta. Theta is 0.6. You minus half. Your R is 15. Your AB 15 and 7.5 sine 0.6. Now be careful, you got to use your calculator in radian mode. Now you can see a D here. D stands for degree. I just change my calculator to radian mode. So you get sine 0.6 radian instead of 0.6 degree. Yeah? If you forgot to change your mode, then your answer might be a bit different or a lot different. Right? Yeah. So this is 35.74. Your answer 35.74 cm square. Right? Okay, number 10a, this is a quadratic function. Yeah, first part is quite easy, solving quadratic inequality. So we have 2x squared plus 5x. The 3 I bring to the left, I got minus 3 less equals 0. Now we can double bracket factorize this. The factor 2 times 3 is 6. So I should use 6 and 1, right? So as you can see, this is 6, this is 1, this is a plus and this is a minus. So we do a sketch. For quadratic inequality, normally we draw a graph, yeah, to find the range of values of x. Your x in this case has the roots are between here, -3 and 1/2. So less equals 0 means the region should be below here, right? We just move it up. Yeah? Remember, more than 0 is the two side above. Less than 0 is the region below. Basically, at x-axis, y is 0, and this whole thing is your y. This whole thing is your y, if you like. You want your y to be less than 0, and your y is less than 0 when your x value are here, right? Anything between -3 and half. So you write -3 x and half. There you go. That's your answer for part A. Okay, for part B, I'm going to do over here. This quadratic equation has two equal roots. Two equal roots, we know our b squared minus 4ac value should be equal 0. So my b is 3q. I square it. My a is p. My c is 4. The result equals 0. So when you expand this is 9q squared minus 16p equals 0. I'm supposed to find Q in terms of P. So let's bring P to the right, 16P positive. I divide by 9. When you divide by 9, you get 16 over 9P. And when we square root 16, you get 4. Square root 9, you get 3. P, you square root, you get square root here. By right, you should put a plus minus. But normally in this question, they will ask you, when they ask express P in terms of Q or Q in terms of P, normally we don't put a plus minus, right? But the marking scheme here, they actually put, okay? So actually it's okay not to put, but if you put it, it's nothing wrong as well, right? Okay, question 11. This looks like a past year question I've done it before. So now here the diagram shows the region of the shaded region here is 10 unit. You're supposed to find the integration of this. Okay, I'm going to do it over here. You're supposed to integrate 1 to 3 x minus 2gx. So I'm going to separate the x and I'm going to separate the 2gx dx. This is part A. And the lower limit is 1, upper limit is 3. So we need to separate them because we need to integrate x. Whereas gx, integration gx, we can use the result from here. Well, when I integrate this, I get x squared over 2. Lower limit is 1, upper limit is 3. I hope you remember your basic ax, and when you integrate this, you copy a, copy x, increase the power by 1, divide by the increased power plus c. Now, for your gx, right, because when you integrate this gx, you're actually finding area under the graph bounded by the x-axis. So you move down towards the x-axis, the result should be 10. Now, because the area is below, when you integrate the result, you need to put a negative in front. Remember, below the x-axis, your y value is negative. So this integration is actually negative 10. Okay, so what I need to do is to sub in the 3 inside. 3 squared is 9. You can actually take out the half and make it easier. Take out the half. 1 over 2. 3 squared is 9. 1 squared is 1. And you plus with minus 2 times minus 10 is positive 20. 9 minus 1 is 8. 8 times half is 4. 4 plus 20. Answer is 24. All right. First part. Okay. Well, the second part, we're supposed to find your gx given g prime x. Okay, g prime x means dy dx. So to find y or gx given your dy dx, I will have to integrate. So when I integrate 2x, I get x squared over 2. I cancel the 2. It's actually like this, 2x squared over 2. Cancel them. You get x squared. Integrate 8. You get 8x. Then you plus c. So to find the value of c, we need a point from the graph. Well, you can see there's a point here. This is 1, 0. So we're going to sub in 1, 0. So that means your gx or your y is 0 when your x is 1. Okay, 1 squared is still 1. Negative 8 times 1 is still negative 8. So this is going to give us negative 7, right? And if I bring to the left, my c is just 7. Therefore, my gx is x squared minus 8x plus 7. All right. Okay, question number 12. So this is a Form 5, Chapter 5, probability distribution. And in fact, this is a binomial distribution. So the probability a student cycle to school is P, a sample of 5 students selected random. Find the value, the probability all the 5 students cycle to school is 0.16807. Find the value of P. Okay, I'm going to do it over here. So they say all the students cycle to school. So that means Px equals to 5. This is 0.16807. Okay, so what I need to do is to use the formula. Now remember, binomial distributions formula is given by NCR, P power R, Q power N minus R. This formula is given in exam. So my N is 5. All 5 of them cycle to school. My P is an unknown, power 5. My Q is also unknown. Is in this case 5 minus 5, you get 0. You got 16807. Now 5C5 is 1, Q power 0, so 1. You're left with P power 5, and it's now 0.16807. To solve for p, I'm going to bring this over. This is power 1 over 5. Or you can write root. You can use the root. I'm going to type in 16807 power 1 over 5. There you go. My answer is 0.7, right? Or 7 over 10. Okay. All right. That is the first part. Okay. I've got my P already. Next, find the probability that more than 3 students cycle to school. So when you say more than 3, so more than 3 means 4 or 5. Okay. Now, I already have 5, the probability of 5. I just have to find the probability of 4. So probability of 4 looks like this. 5 choose 4, B power 4, Q is B 0.3, by the way, B is 0.7, Q is 1 minus B. Yeah, your Q is 1 minus B. In this case, 1 minus 0.7 is 0.3, power 5 minus 4, which is 1. Then you plus with 0.16807. Okay, let's calculate this. 5C4 is just 5. Then you multiply with 0.7 power 4. And then you multiply with 0.3. So whatever you get here, we just add with 0.16807. 16807. There you go. 0.5282. Now you don't have to give too many decimal points. Yeah. 52824 decimal point is good enough. All right. Okay, let's move on to section B. Question number 13. Here we have 5 pieces of card chosen from the at random to form a code. Yeah, from the word special. Yeah, this is a special question actually. So find a number of ways to arrange all the letters in a row if all the vowels must be next to each other. Okay, I'm gonna do it here. Now I'm gonna number one, I'm gonna understand I'm only arranging 5. I don't arrange all. I got 7. Now when we say vowel, we are referring to E, I, A. Your consonant, we are referring to S, B, C, L. There are 4 consonants and 3 vowels. So if all the vowels are next to each other, very simple, we just tie the 3 vowels together. Yeah. So here we have E, I, A. And remember, we are arranging 5 only. So you must have 2 more consonant. Yeah. But the consonant I'm choosing from 4. I got 4 consonants to choose from. I've got 3 vowels. I'm arranging all of them. So for the vowel, we say 3, 2, 1, or 3 factorial. For the consonant, we say 4 times 3 because we are arranging 4. Our 4 we arranged 2. So we can write like this, 3 factorial times 4p2. 4p2 is the same as 4 times 3. Remember, 4p1 is 4, 4p2 is 4 times 2, 4 times 3, 4p3 is 4 times 3 times 2, 4p4 is 4 factorial, right? So you can write that if you want. So, but the thing is, this EIA, the box of containing the block of vowel, they can appear first. You can put them first. You can put them, should I draw here? First. You can put them second. You can put them third. So there are 3 ways to arrange them. So you got to times 3. So what we have here is 3 factorial multiply with 4p2 multiply with 3. My answer is 216. Okay. First part is not too difficult. Okay. Second one. Okay, this is still Roman part A, yeah? Roman 1, Roman 2. So at least 3 consonants are arranged side by side. Side by side is the same as next to each other. So here we're going to consider a few cases. Now, when you say at least 3 consonants, we can arrange 3 consonants. Okay, case number 1, 3 consonant, 2 vowel. All right. So that means that I only have exactly 3 consonant, and I have 2 vowel here. Right. So how many ways can we arrange a consonant? Now remember, I got 4 consonant to begin with, so it's 4, 3, 2. Now 2 consonant, 2 vowels must be coming from EIA, so it's 3 times 2. And again, similar to just now, I have a block of 3. I can put the block in front, middle, last. So that's why number of ways you can write this as 4p3, and this one you can write 3p2. 3p2 is 3 times 2. You multiply by 3 because there are 3 different ways to arrange them. You can put it first, second, or third. So let's do one by one. 4p3 times 3p2 times 3. So this gives us 432. Okay. Now, we also have to consider second case because in the first case, we have exactly 3 consonants. They are together and you got 2 vowels. How about 3 consonants, right, together, 1 vowel and 1 consonant separated? That can also happen, right? So we can write 3 consonants together, 1 vowel here, and 1 more consonant being separated. So in this case, we say 4b3. Well, actually, you can actually write 4 factorial because it's 4, 3, 2. We arrange them. The last consonant, you have no choice to put here. So whether it's 4p3 or 4 factorial, they're actually the same, right? But for the vowel, you have 3 vowels. So there are 3 ways to arrange them. You can write 3p1. You can times 1 or 1p1 here, up to you. You want to write 1p1 because this last consonant that I have that I need to put in here. Then I multiply by 2. Okay, be careful this one. I cannot multiply by 3. Why? Because I want the 3 consonant here, 1 vowel here, 1 consonant. This is one way. I can also have 1 consonant, 1 vowel, and 3 consonant together. I cannot mix them up. I cannot say, oh, I put the consonant in the middle, 3 consonant in the middle, and 1 consonant here and 1 vowel here. Why? If I do that, then I'll have 4 consonants together, which we're going to do for the next case, right? So since I'm using case number 2, so I just times 2, okay? Well, let me just erase this. Okay, you don't have to erase that for you to see. Okay, so you just times 2. You cannot have this case because if you put consonant, 3 consonant in the middle, then it will be next to the consonant, the single consonant there. Okay, so let's count. This is 4p3. Oh, actually, you can just use this. 4p3, 3p1. 1p1 is just 1. If you want, you can still write that. 1p1 is just 1. And then I times 2. This gives us 144. And lastly, case number 3. I know this is very long. We have 4 consonant and 1 vowel. Because the maximum consonant that we have is 4, right? 1 vowel. So that will be 4 factorial, 4, 3, 2, 1, right? Move this out a bit. And 1 consonant. There are 1 vowel. There are 3 vowels. I put 3 there. So we can write this as 4 factorial times 3p1. But remember, you got to times 2. Why? We can put the block of consonant in front or at the back, right? You do times 2. So in this case, is 4 factorial times 3p1, which is 3. You times 2. You still get 144. Okay, I know it's very long. You got to find your total. My total is 432 plus 144 plus 144. Let's count. It's basically 144 plus times 2 plus 432, 720. All right. Oh, we are still not done. This is just the first time for permutation. For combination, yep, we have this, the NCR formula. Okay, so here the NCR, I hope you know that NCR is defined as n factorial, n minus r factorial, r factorial. Okay, maybe in my other video you can, I will be able to explain to you why is it so. Okay, now here we want to go straight to how to apply the formula. This is n factorial, n minus r factorial, r factorial. As for the second one, you have n minus 2 factorial. Your n is now n minus 2. You got to divide by n minus 2, u minus r factorial, and your r factorial. Now, here's the thing. Your n factorial, you got to break it up to n minus 1, n minus 2 factorial. For example, like if you have 5 factorial, we can say it's 5 times 4 times 3 times 2 times 1, which is basically 5 times 4 times 3 factorial, right? The reason why I do that is because I want to cancel my n minus 2 here with my n minus 2 here, right? With the factorial there, right? I want to cancel them off. So, well, what we can cancel for the denominator here is this. I can cancel this first, right? Let me keep writing the n minus r factorial, and this is n minus 2 factorial, whereas the n minus 2 minus r, to avoid confusion, let's do n minus r minus 2 because they are the same. Now, take note that the r factorial already cancel out. Now I cancel out this one, right? And again, I'm going to repeat the same trick. This is n minus 1. This n minus r, right, is actually n minus r minus 1, and n minus r minus 2. Okay. And I have a 1 over n minus r minus 2. Why do I break this up? Because I want to cancel this 2. Okay. Now, I know this looks a little bit complicated to simplify. So I'm going to multiply this over. This is going to be n. You can expand it. I'll just expand it. N square minus n. For the second one, right, I think it's actually easier for you to think this way. Think n minus r, n minus r. Easier to expand. So this will be n minus r square minus n minus r. Isn't it? When you're multiplying inside. Easier to see. Let us simplify n square minus n. This will be n square minus 2nr plus r square, and a minus n plus r. Now, notice, again, we can cancel minus n here. I can cancel n square here. So this is now 0. This is minus 2nr plus r square plus r. Well, it's a lot of algebra involved, yeah? The combination part, the only thing it tests you is the formula, how to use the formula and simplify it. The rest are just algebra. Since I'm finding n, I'm going to bring it over. 2nr is r squared plus r. Well, your r can't be 0. We can actually divide by r. Yeah, let me just cancel the r off, right? And divide by 2. Your n is r plus 1 over 2. Okay. Okay, question 14 is from differentiation, form 5, chapter 2. Okay, so number 1, I have to differentiate dx dt, right? So it's kind of easy to differentiate this. Differentiate dx dt. Let me write over here, right? Your dx dt, bring the power down, you should get 3d squared. As for -6, when you differentiate -6, you get 0. Okay. I got my dy dt. I want to find my dy dx. Now, we know using the chain rule, dy dx is, you can split into 2. This is your dy dt. This is your dt dx. My dy dt, I already have it here, is 9 over 2d power 5. dt dx, I have to take this and invert it, 1 over 3d squared. I can cancel 9 and 3. I get 3. I can cancel d power 5, d power 2. I'm left with d power 3. So this is 3 over 2d power 3. All right. But here's the thing. I want to find dy dx in terms of x. Yeah, this is Roman 1. This is Roman 2. To find dy dx in terms of x, I need to get rid of t. Now look at this. Your t cubed, if I bring the -6 over, I got x plus 6. So I need to take this t cubed and substitute with x plus 6. Yep. Well, actually, you can stop here. But if you want, you can expand this. When you multiply inside, 3 times 6 is 9. 9 divided by 2. 3 times 6 is 18. 18 divided by 2, you get 9. Yep, you can leave your answer like this as well. All right. That is part E. Okay, part B, I'm going to do it over here. We have a coordinate. You're finding a coordinate of a point on this curve such that the gradient of normal is 1 over 5. So in a linear law question we did just now, also we have 2 lines as perpendicular.
right? We know when you differentiate dy dx, what we're getting is gradient of tangent. So here you're getting a normal. So tangent times normal, we know is -1. We first find the gradient tangent. Gradient tangent is -5. Yeah. M1 dot M2 equals -1. So you remembered that. Okay, next we're going to differentiate this dy dx. This one involving composite function. When you differentiate composite function, you bring the power down. You want, I can write this formula for you. This is, it can be any function and not necessarily linear form. So when you differentiate, you bring the power down, you copy the bracket, you reduce the power by 1, and you differentiate whatever inside the bracket. So here you bring the power 3 in front, you copy the bracket, you reduce the power by 1, you differentiate, you get -15, and 3 times -15 is -45. This is 3 minus 15x with a square. Now, remember dy dx is what? Dy dx is your gradient tangent. My gradient tangent is -5. I sub inside. When you divide this, right, this is 1/9. This is 3 minus 5, 15, 15x with the bracket square. So what I need to do is to square root both sides. When you square root this, there's a plus minus. So let's do one by one. Maybe I start with a -1. And I write the +1 separately. 3 minus 15x. Bring the 15x to the left. Bring this to right. Now, I know a lot of people don't like fraction. Maybe if you don't like fraction, you just multiply by 3. Okay? So this is 45x equals to 10. 10 divided by 45, 2/9. The second one, I times with 3. 9 minus 45x. 45x is 9 minus 1 is 8. X is 8/45. It's not a nice number. That's the problem. But it's okay. Some numbers can be ugly, but can't help it. Now, we got your x value to find your y value. Sub inside. You're finding the coordinates, right? So it's 3 minus, okay, let me write nicely. 3 minus, let's move this down a little bit so you can see. Okay, you can see the whole question. Oops. All right. I need to put 3 minus 15, 2/9, and a square. Sorry, it's not a square, it's a cube. So you can use a calculator here. This is a 3 minus 15 with 3 minus 15 with a 2/9. When you close bracket, you cube it. My answer, -1/27. The second one, we're going to put 8/45 inside. You cube it. Okay, let's change this to 8/45. 8/45. Okay, and I got 1/27. So we have 2 points. The first point is 2/9, -1/27. The second point is 8/45, +1/27. Yep, 2 possible coordinates. Right. Okay, last question. This is a very interesting question because you're supposed to derive the formula on completing the square. All right, so I'm going to show you over here on the right-hand side. So basic formula for quadratic, the quadratic formula by completing the square. All right, so it's actually not difficult. It's just that we have to give answer, in terms of unknown. So remember, in the process of completing the square, the first thing is you need to ensure that your coefficient x squared is 1. If it's not 1, you make it 1 by dividing it by a. Your a is your coefficient x squared. So this is b/ax, and you have a c/a. Now you may want to bring the c to the right-hand side. Okay, up to you. You bring it over. So it's x squared plus b/ax negative c/a. Now you can, some students, they add on left, add on right. You can do that, use that method if you want. Now I want to, I'm not sure whether you are familiar with this. For me, when I complete the square, I take half of coefficient of b. In this case, b/2. Then I square it. Then immediately I minus with b over 2 square. Why is it so? Because when you expand this, you get x squared, 2ab, which gives us bx, and then you have to take your p over 2, you square it. Now, you minus it in the first place because you want to cancel this so that this expression is the same as the one above. So likewise, what is my p here? My p is b over a. When you take b over a divided by 2, you get b over 2a, and then you square it. Now, when you square this, I must minus the same thing here. All right, then this is now negative c over a. Okay. Next, we are going to square this, so you can bring over to the right-hand side. I'm going to square it first. X plus b over 2a. When I square this, I get b squared over 4a squared. This is minus c over a. Let's bring this to the right-hand side. When I bring over to the right-hand side, this is now b squared over 4a squared minus c over a. So what I'm short of here is a 4a because I need to get 4a squared, right? Remember, you want to combine a fraction, they must have the same denominator. Yeah, my c over a doesn't have this 4a squared, so I multiply by 4a. So when you multiply the numerator, the top part, you get 4ac, and the bottom part is 4a squared. Now remember, on my left-hand side, I still have a square. So you got to bring the square over, right? When you bring over the square, you have a plus minus with the square root. B squared minus 4ac. 4a squared, when you square root, you get 2a. Look at this. We're very close to the final answer. Just bring this over. X is minus b. Since this is 2a, this is also 2a, we can put it together as 1. B squared minus 4ac over 2a. There you go. We managed to get the quadratic formula. All right, part B I'm going to do over here. They say this is part B here. Use the quadratic formula derived from A to determine the roots of this quadratic equation. Give your answer in imaginary number where I is square root negative 1. Now, a lot of people got shocked. Say, what is this? Square root negative 1, yeah? Is I. What is I? Well, don't worry so much about it. Just replace your square root negative 1 with I. Yeah, your answer will be I. Yeah, we actually do this in A levels, right? Not Form 5, but it's not to say very difficult. Okay, so I already know my B. Guys, use your formula over here. We will have this formula. I know my A is 9, my B is negative 6, my C is 5. So use the formula minus B plus minus square root B squared minus 4AC over 2A. So here we have 6 plus minus square root. This one here, you might want to use a calculator, right? Minus 6 square is 36, minus 4 times 9 times 5. So I got negative 144. Okay, negative 144. Now, I know a lot of people would be shocked. Say, square root negative 144. Oh, I got math error. So this calculator, you can actually do something like this. Mode, you go to number 2, complex. This is called complex number. When you square root negative 144, you notice they will actually simplify for you is 12i, because square root of negative 1 is just I. I stands for imaginary number. Is what they say here, right? So you have to divide by 18 here. Don't worry, we can just simplify this. We know square root 144. You can write separately. Yeah, is actually square root 144 times negative 1, which we can split into 2, 3. This is still 6, right? Okay, let me write over here that more space. This is 6. Square root 144 is 12. Square root negative 1 is just I. You divide by 18, right? You can write one extra step. Square root 144 times square root negative 1. Yeah, you can do that. So divide top and bottom by 6. You get 1 plus minus 2i over 3. Or you can write as a single term like this, or you can write separately 1 minus 2i over 3, 1 plus 2i over 3. There you go. Well, we're done for this chapter, the discussion for this test paper. I don't think this is too difficult, but there's a couple of questions that's a bit challenging. This is one, yeah, especially when you have to derive the formula. But generally, the paper is not too difficult, right? Thank you so much for watching. Yeah, I hope to see you guys in the next video.